Gonna keep going from my previous video where I was working on the nested structures thing, and that video ended with a bug. Basically, the C interface wasn't working anymore. It wasn't exposing the symbols we were expecting. But I had to stop to do a few things, and as soon as I came back, I noticed that the structures were not public. So I think I mentioned in that video that I was making sure that things were public, but I was only looking at the functions, basically, not the structure. Um, and the structure also needs to be public, apparently. So one thing I'm gonna do very quickly, I'm gonna change the way we expose structures to always add, to basically always make them public. This is gonna be in drive c.rs. Yeah, I'm gonna do it like down here. It's called vis usually, like visibility. Yeah. So this should make sure that, let me try removing it. Okay, so yeah, so pub struct and pub struct. Okay, so now we should have our symbols, I think. Yeah, so we have inner new, inner get val, inner set val. We should also have some outer, I think. Those are not present, so oh yeah, because I already did cargo expand. Yeah, I should build. We can just make for that. Oh, okay, so this is working now. So yeah, we could also switch back to GCC. That was not the problem. Okay. Okay, so we were basically trying to copy the Python example and reproduce in C. So this is the Python example. Create a new inner object, wrap it inside an outer object, print the value, update it, and print it again. So here we're printing it, and in between we need to change it. We can't really do it this way in C, or maybe we could if we make the structure non-opaque, because in this case we don't really have anything weird inside. So we could also make it non-opaque. Yeah, let's try. Okay. So now we have access to the structure, which means, I mean, probably the constructor and the getter and setter are not really needed anymore, but we're still gonna keep them. But yeah, this means that I can look basically inside the structure itself. And I could even probably make this one not opaque at this point, I guess. Let's see. Okay, it's not complaining. Yeah, so now we can look inside both structures, which means that we can pretty much remove all of that and maybe just do this. I don't know. yeah, so yeah, this is a more normal way to look into structures in C. Now let's just try to change it. Oh, okay, that's working. So this is pretty cool. Yeah. So yeah, that makes sense. So if we only have uh, so yeah, if we have complex type, we can like make the inner, so basically the equivalent of the inner structure, make that opaque, but then make the outer structure not opaque because we only have uh, C safe types as our fields. So yeah, this is pretty cool, I think. Yeah, we can also probably just initialize the structure directly, I think. Um, is it? I don't know exactly how this is done in C, probably like that. I have no idea. Is it dot val? Yeah. So don't need this one anymore. Oh, this is actually probably pretty dangerous to do because I'm taking a reference from the stack. So yeah, I mean, it's fine in this case. It can get dangerous, I think. But oh no, actually, uh, this is probably pretty dangerous because if I change this like that, this should probably work, I think. Yeah, so this works. The problem is that we assume that our pointers are um, on the heap. Uh, basically, the way we free those pointers. So somewhere around here in the setter, basically. Yeah, like in the setter, we assume that the pointer we have actually comes from the heap, which means that we can uh, move that, like create a box from that pointer and then free that. And I think probably bad things would happen um, like this because in this case this is a pointer from the stack. So yeah, this is not really. I guess we should either have the getters and setters or make the structure non-opaque, like either one or the other, not both of them at the same time, because yeah, otherwise weird things can happen. So yeah, we should find a way to hide those. Actually, not those. To not create getters and setters if the structure is not opaque in C at least. So it should be pretty easy, I think. So yeah, right here we have, if it's not opaque, we add that. Maybe we could just have yeah, I don't know if I can reproduce. First, I should maybe try to like reproduce the issue I'm mentioning. Um, so basically, if let's say I create a different inner object with a different value, and then I try setting using a setter this time. Um, I try changing the inner using the setter, which is like outer set inner. Uh, so yeah, if I try to do something like that, in here it's probably gonna try to free the pointer we have to I, but this is on the stack, so I don't really know what's gonna happen, but probably not good things. Yeah, invalid pointer. Yeah, so we definitely shouldn't do that, or at least we shouldn't allow that to happen. So I guess the solution is just to remove getters and setters entirely. So I mean, now this is not gonna compile because because those functions didn't exist anymore. Oh, why did this type change? Oh yeah, because we still so we should still wrap the type, I guess. Mm. Yeah, because now we only wrap the type if we are creating the getters or the setters, either one of them. But now we're not creating it anymore. So what type does this thing have? Actually, this should work as well. Yeah, we don't really need to use pointers or anything. We can just do this, I think. Yeah, obviously this doesn't exist anymore. So basically the equivalent is to just do, yeah, so this works, yeah. I don't know, I'm trying to figure out if this is a bad idea for some reason. Maybe like the size of the structure, the fact that we don't store a pointer, we store like the whole structure inside, but it's probably fine, I think. Yeah, this is probably fine. We could also do, like, if we don't wanna generate the getters, because like in this case, we don't really, we would only need them for Python. We don't really need them for C. We can probably use CFG after, I think, which I don't remember exactly how that's used. But... Okay, so it's like the condition and then the attributes. So we shouldn't have those getters and setters anymore. No, they're still here. What? Oh yeah, because it's not just the attribute, it's the function itself that we should not um, generate. Yeah. Why are those serial? What? Oh, I'm afraid maybe I'm just removing those attributes. So yeah, so I'm just, yeah, this is another bug in here. The fact that we completely remove all the attributes, I think. We shouldn't really do that, I guess. So should have maybe something like this should work. Yeah, this is gonna break because it doesn't understand. Yeah, but that's fine. We can just remove those when we see them.
Hey, Alakos.
Oh, where is Discord? Hi, Steve.
Hey. Oh, are you live? Sorry. Oh no, you're
Yeah,
streaming?
I am. Don't worry. It's fine. So if you have any questions or anything, just ask them. It's probably gonna be. I mean, I think people that maybe are gonna watch the recording later on, they're gonna appreciate if you ask questions and everything. Because I'm
Okay.
just talking to
I'll try
myself,
to
but
try to ask some good ones if I think of any.
yeah. So this is not really like related to what I was doing yesterday. I mean, it's still the same project and everything, but this is more. I'm basically just adding new stuff, not really explaining um,
Okay.
the code anymore. I was trying to uh, basically fix that thing. I think I described that on Discord a while back. It's nothing here. Like, yeah, the
Is this
problem.
related to be just oh, okay.
Sorry, go ahead.
Oh, this is related to the language binding, or is this just general BDK stuff?
No, it's still the bindings.
Okay.
This is
Okay.
the
Oh, this
that
discussion from yesterday.
yeah that thing where you can't like change a nested structure or things like that. So now it should be working.
Uh,
I got
ah,
it to work pretty well in Python, at least in the previous video that I did a few hours ago. Then I had a
hmm.
problem. So at the end of the video, I also did the C part, but it was not working for a pretty stupid mistake. I forgot to make the structure public, so it wasn't exposing them basically. So in the end, I
Oh,
just
I see.
changed the like procedural macro to always add. Um, let's see, what is it? So yeah, basically right now we always add we always make the every structure public by default, because yeah, that's probably
Okay.
what you want. If you are trying to expose a structure, you also need to make it public, otherwise Rust is not gonna expose it. They have this policy where I think it makes sense. So if you have something that's private, which it will be private to other Rust crates, they also make it private
Mm-hmm.
to other languages, basically to also see and everything, which yeah, probably makes sense.
Yeah, that makes sense.
So yeah, so now the C part is pretty much working. I realized that the way I
I
was
see. So
doing it,
this, yeah.
sorry.
Sorry. So this is the code that basically takes your Rust code and then creates some new Rust code to expose it in a more C friendly or FFI friendly way, right?
Yeah, exactly. So like
Okay.
the thing I'm doing right now, um, basically, the point is that different languages they need different functions. Or for instance, in this case, C can look directly into structures, but Python needs getters and setters. So
Mm.
I was basically uh, doing this thing where you can have the getter only under Python, or potentially other languages in the future. But right now, like this function is going to
Yeah.
exist only if you are under Python. So I'm trying to fix those stuff because I realized when I was exposing a function, I was completely removing all of its attributes. So this was basically disappearing, and the function was still showing up because obviously I was removing this conditional thing. So now I'm basically just copying over the attributes, but also changing them potentially, but copying all the one you have on the original method. And I need to basically ignore some of those because those are only used really in Python, like the constructor or getter and setter. Those are mostly used by Python, and C basically doesn't really care about them. So I'm just
Right. I
gonna
think Java
ignore
will
them.
probably work this way also. Like Java will have a constructor and a
Yeah,
getter and setter on a
yeah.
structure most likely.
So yeah, probably most languages, like at least object-oriented languages, they're gonna use them. It's just C that doesn't really care
Yeah.
about them. Um,
Yeah.
so yeah, I don't know where. I think I should copy some code over from Python because I remember in Python I have a piece of code that ignores the destructor because in Python the destructor is handled by PyO3, so they do all the
So they
destruction
add.
stuff themselves. Yeah. So we don't need
Okay.
like an explicit destructor that we, for instance, we did in C, because if you have a
Mhm.
complex structure to free, you can't just free the pointer. Maybe you have nested stuff that you need to free first. So in C, basically, you need a destructor for complex types. But I know we
Right.
ignored that on Python, so I'm just gonna copy the code to ignore the destructor from Python and I'm gonna adapt it for. Yeah. Is it like readable? Is it too small, the font I'm using, or?
Looks fine on my screen. I'm gonna have like a desktop screen, but it looks fine.
Okay, so that's, yeah, I think it should be like kind of average size, but I don't know.
Yeah.
Okay, so we're already doing some stuff. So if we are a destructor, we do something specific. Um, Maybe I should make like a list of attributes that we don't care about. Uh,
Mm.
which is like, uh, mm, how would I do this? Oh yeah, so if we find one of those, we just remove it.
Mm. So the code we're looking at here is your procedural macro. So what we're talking about here are
Yeah,
language syntax pieces.
yeah. So this is there's a really cool crate which is called scene. I think I guess it stands for like syntax. They have all the
Ah,
parsing functions. So basically, what you get from the Rust compiler is just
ah,
a bunch of tokens. But then with this crate, you can
mhm.
parse those tokens into useful stuff. So for instance, right now I'm
Oh,
working
nice.
on a item fn, which is what you get for every function.
Uh-huh.
And item fn as a vector of attributes. So I'm like iterating on the attributes, looking
Right.
for specific ones that I know I want to remove, and I just remove them from the vector.
Very cool.
And then at the end, you can turn, like I take a token stream, so just a bunch of tokens, I parse that into like one of those structure which is well structured and everything. I make all the changes I need to
Mhm.
make, and then I reconvert that into a bunch of tokens again because the compiler wants you to return some tokens again.
Yeah.
But it's obviously much easier to operate on those rather than just working with single tokens.
Yeah.
So there are
It's all
traits like,
parsed for you.
yeah, there's this two tokens trait, which means that this
Mhm.
thing can be the main two traits are parse, which means that you can take a token stream and make one instance of the structure, so you can parse some tokens into a structure. And then there's two tokens, which is like the opposite. You take the structure and you turn that
Hmm.
into a token stream.
And then that token stream that you end up with, that basically gets fed back to the compiler, and it just gets fed to the
Yeah,
object, yeah, the output object code.
yeah, it basically replaces, like if I tag, I don't know, like this module,
Oh, I see.
the
I see.
compiler gives
It
me,
replaces that piece.
yeah,
Yeah.
I get all the tokens of this module, and then the compiler replaces that with whatever I return. I could return even not a module. I could
Mhm.
return something else. It doesn't really matter. Just tokens
Right.
coming in and tokens going out.
Yeah. And in the Java language, there's a similar concept called reflection, where you can kind of look at code and change it. But this is quite a bit more advanced, it looks like.
Yeah, I think it's very powerful. Like I don't really know how many other languages let you, I don't know, do this kind of stuff. This is like a compiler plugin almost.
Yeah.
Uh, yeah,
Yeah.
it's very
Yeah.
powerful.
In Java, all it lets you do is it lets you kind of run code before and after and
Oh, okay.
potentially modify the input attributes, but or the input arguments, but that's about it. This is like actually
Yeah.
rewriting the code.
Um, Actually, I don't think this would work. No, okay, it would probably work because I need to mutate attrus, but yeah, it's not. I'm not borrowing from it. I'm just getting out a
Hmm.
position. So in this position,
So
it
I guess,
shouldn't.
right. So the reason you're doing these, you're ignoring these, is because if you want to potentially add a constructor, getter, or setter in your original Rust code, you wouldn't want to get it overridden, right? Is that
No, it's
is that
mainly just because, like in Python, I leave them there because Pio3 uses them, so Pio3 understands them. But if in C, I ignore them, so my procedural macro ignores them, and there's no other macro that uses them, so they end up in the final code, and the compiler complains that it doesn't know what those are because this is like adding a random attribute to a random piece of code, and the compiler will tell you that it doesn't know what that attribute is doing. So usually the way this thing works is that um, a procedural macro looks for attributes it understands and then removes them um, because I mean, they've already been processed, so they don't need to stay there anymore. And whatever is left in there, um, if the compiler doesn't understand it, it completely fail compilation. So like the error I'm getting now is I have no idea what constructor means because
Oh,
this
I
this is
see.
not a
I see.
Rust attribute. It's just kind of a random tag that I
Hmm.
use. But whenever I use it, I should also remove it. Otherwise, yeah, it remains
Yeah.
in the final code.
I see. I was misunderstanding what attribute meant. This was a not a function name. It's those macro tags basically.
Yeah, those are
That's
called
what you were looking
attributes.
for.
Yeah,
Yeah.
those things.
Other attributes. Okay.
Yeah,
Yeah, that's that. Understand that.
there are
Okay.
also like special cases, like for instance the doc. Like whenever I add, like if I add a documentation comment like this is
Hmm.
actually turned into an attribute. So this becomes, I think, something like this.
Oh
Wait,
yeah, doc
yeah,
equals. Yeah, we've
equal
done that
whatever.
before in the BDK code
So yeah, you can
as a
also,
workaround for bugs.
yeah, so you can also operate on those if you want. These are all
Yeah.
attributes. So you can have a procedural macro that generates documentation. For instance, you add new attributes like
Hmm.
these, or you can remove them, or yeah, whatever.
I know that I'm pretty sure the LDK version of this that Matt Corallo's doing, I think he uses the doc attributes as part of his scheme. I haven't spent a lot of time yet looking at it, but anyway, I kind of, yeah,
Yeah,
I know that he uses those, and it kind of does make more sense to me though to use the more structured kind, like you're using the actual macro kind of. I mean
yeah. I
the
haven't like really look at
yeah, it looks actually like an attribute.
yeah. I don't know. I haven't really looked at this code. I think he's parsing Rust code, but he's doing it
Hmm.
like in Python or something. Like he's doing it externally, not using Rust tools
Okay.
or anything. I have no idea. I think it just had like some Python scripts that would run on Rust code, and I
Hmm.
think it would extract whatever it needs to extract from the Rust code itself. But I don't know.
Right, right.
Maybe I'm just saying. I don't know. It's just kind of an assumption, but I'm not sure.
Yeah. No, this is.
So I think this is function.address. Yeah. Okay. Why is that? Oh, okay. Okay, you want. Okay. Okay, so this compiles, and basically this is now expanded to, where is it? Oh yeah, it completely removes them because, yeah, it makes sense. So these, like these two, the getter and setter are completely missing, because yeah, I'm compiling with the C feature, and those are only enabled in the Python feature, so they just don't exist anymore, and they should also disappear from the bindings here. So we only have the basically constructor. Um, this doesn't really hurt. So basically the problem I had with getters and setter was um, not really in those setter, because those are pretty simple. In the setters that I automatically generate for complex types, I was basically always assuming that the pointer inside of a structure was allocated on the heap. But you could, like if you have access to the structure like this, you can see what's inside the structure. You could set uh, like something inside the structure with a pointer from the stack, and then
Mm.
I would try to free a stack pointer as if it was an heap pointer, and it was crashing because we can't really do that. So basically, there were
Okay.
two ways to write stuff inside of a structure, and there was one way where you would do it manually, and one way through the getters and setters. And if you mix those up, it will break. So I'm just removing setters. The idea is that if the structure is not opaque, so you can see inside, I can just remove the getters and setters. So there's only one way to access it, which is just taking the inner uh, members. I don't know how these are called in C. Um, but yeah, basically the ways there should be only one way to do it, and so you can't accidentally mix them up and cause issues. So if you make the structure non-opaque, they're gonna disappear. And in theory, if I make these opaque, uh, they should come back.
Mm.
Um, well, it's probably, yeah. So the C part
Yeah,
doesn't
is
compile
it?
anymore,
Mm.
but yeah. So I get
I'm wondering,
back
is it?
the getter and
Yeah.
setter.
I just wonder. It seems like if is it even necessary to support non-opaque structures? Um, I don't
I
know. I'm like, I just, yeah. I mean, I
I
guess
don't know.
I
Sorry,
mean,
go ahead.
if it's doable, it's good. But I'm just wondering. I wonder if it's going to cause some like potential risks in terms of like having the C code pointing to a Rust structure. I guess you've made a copy of the Rust structure is what you're passing out. So I guess you couldn't get into any unsafe conditions.
Oh, yeah, one thing I should point out, you can only do that if every member of your structure is also like C safe. So for instance,
Okay.
if I have a string in here, this is not opaque. If
Mhm.
I yeah, right now I only have the U32, which is just an integer, so this is like C safe.
Right.
It's fine. It's the same thing in both languages. But if I start adding
Mhm.
complex types, like string, um, it should, well, I should also initialize it, otherwise it's gonna fail in a different way. But string, yeah, something like that. Is there? Yeah, also in here. Okay, so this is probably gonna complain. It doesn't really fail. I think it only gives a warning.
Mhm.
It didn't. What? Okay. So yeah, usually the warning is like, this is not FFI safe.
Oh yeah, I think we said that yesterday.
Yeah. Okay, so it's declaring it. No, this is probably wrong. Maybe it's doing this because I'm not using it or anything, so it can kind of get away with declaring it as a fake structure because I never do anything on it. I don't know.
Oh, it's not accessed.
Oh no, actually, no, it's fine actually, because the point is that you don't know. No, this shouldn't. Yeah, no, this is probably wrong. I think this is C bindgen generating the wrong header. It shouldn't really let you do this because the C compiler doesn't know the size. So this is probably gonna break. Like even if I make an empty C. Wait. No. Why did? Okay. Yeah. So I think this is C bindgen generating the wrong bindings. Basically, the C compiler doesn't accept this header because it doesn't know the size of string. So the error is
Okay.
string as an incomplete type because this is inside of a structure, so it should know how large this is because it needs to know how large
Mhm.
the whole structure is. So this is fine. This is
Mhm.
32 bits, but it doesn't know about this one. So yeah, it's weird that the Rust compiler didn't say anything. But yeah, the point is you can only do this if you have C safe types. So if you only contain types that C can understand, it's fine to be non-opaque. Otherwise, you have to be. So
Okay.
yeah, this was just kind of an
Right.
example. It didn't go the way I was expecting, but yeah.
Yeah, no, but I see. As long as there's, I mean, yeah, just there'll be somewhere that catches it so that you don't get into that situation. I guess I wasn't thinking so much the memory allocation. I was thinking more like, if you give if it was like an element of that structure that C could, um, I don't know if like C could be pointing to it, but if it was the same, if it represented actually a pointer to something in Rust, then Rust could deallocate it and screw up the C side, or um, or vice
Yeah.
versa. I guess C could override it somehow.
I mean, in a way, it can always happen because if you only write like pure Rust code, the compiler can check every lifetime of every variable and make sure that you're not using something after it has been dropped. But as soon as you start like passing pointers in and out of C, like you could have perfect
Mhm.
Rust code, but you pass a pointer to C and then C changes it, and when it gives it back,
Yeah,
it's not the same thing it was anymore. So there is a little bit of
right.
unsafe code because of this. But yeah, the idea is to
I guess
try and making it very hard to do that accidentally at least.
yeah, yeah. It's an inherently risky
Yeah,
operation, but yeah, you can add some guardrails.
yeah. So this is fine. So I don't know. I think with this I could go back to map BDK stuff. So I
Hmm.
started doing this thing when I got to the point where I was mapping the transaction inputs. So I was starting to make pretty complex structure where you have a transaction input which contains um, other exposed structures like outpoint and scripts and things like that. So at this point is where I realized that there was that like bug that was not updating stuff. Uh, and now it looks like it's kind of fixed, I think.
Hmm.
Um,
I just are you just going through each of the sort of the common BDK structures and functions and just seeing how they get mapped to see if it mapped correctly, sort of thing?
Not really. I mean, I have to do it manually, so it's not like I have to manually define which structures I wanted to expose. So like it's basically in here.
Right. Okay.
So there's like this
Oh,
Bitcoin
I
mod
see.
which is exposing things from
Uh-huh.
Rust Bitcoin. So I define a script structure that contains, this is opaque because it contains the script from Rust Bitcoin. So obviously it has a like weird layout. It's not C safe, so the structure is opaque. And then I implement a few methods on that, like a constructor that you can create a new script from basically a vector of bytes. The destructor, and then maybe some utilities like empty to create a new empty script from X to X. This is to get like the kind of assembly, like the opcode representation of a script. And I just do that for every thing I want to expose. So I do that for network, for address, and now I'm just working through. I mean, I'm not going to expose the entire Rust Bitcoin, only the things we need for BDK. But yeah, it's quite a bit, quite a
Right.
large chunk of it.
Yeah, but this is common code that any language binding would share all of this. I mean, this wouldn't be per language. This is for all
Yeah.
languages basically that we're going to support as a binding language.
Yeah, exactly. So this is the point. This is something that you should write only once, and then you can basically target this to all the different languages, and they're going to show up in different ways. Like in C, those are structures. In Python, those are classes. But yeah, so this is the idea. So this is kind of painful to do for every single structure. But the alternative would be to have like a Python, like one specific crate that does this for Python, and then one for C, and then one for Java. And every time you make a change, like in BDK, you have to go through all of them, and it's even more painful. So this is, you just have to do it once, and it should work for every language.
I guess the good news is there should be a somewhat limited number of primitives that need to be exposed, at least for BDK. You know, like I think you said it's not the entire Rust Bitcoin library. It's just the pieces we're exposing through our APIs.
Yeah. I mean, I think exposing them is not super hard. I think the hardest part is going to be make this like very usable in other languages. Like, I don't know, I remember there were a few structures that I exposed, and then I realized they were missing getters and setters. So, I mean, it was working, but you couldn't really do much from the outside, from like C or Python, because you didn't have any way to access what's inside. So yeah, it's gonna be, I think, probably kind of a long, process, adding all these useful methods here and there.
Yeah.
Okay, so, oh yeah, I need to kind of refactor a few things. Because yeah, this is the thing I was describing in the previous video, but basically the idea is that if you want to generate, this is like a syntax to automatically generate getters and setters. And the reason why sometimes you have to do them manually is that, for instance, this only works for classes in Python, because basically instead of, in the getter, instead of returning a cloned copy of the item, we return basically a reference to the same item. And you can only do that for classes in Python. So I can't do that for like a U32 for like a number. So the idea is that for simple native types that are not like nested or anything, you just write the getters and setters this way. Actually, this is a complex type, so maybe it's more like for value. Value is a U64. So for value, it makes sense to just have the simple getter. Maybe eventually we'll get to the point where we can also automatically generate those. But yeah, right now those are very simple, so you can just write them manually. And instead, those getters that are more complicated, that need to make a cloned reference and things like that, you use this syntax, so it will automatically generate it for you. But the problem is that this changes the type inside. So this structure, when you, for instance, when you expose this to Python, it will change. It's not going to be an out point anymore. It's going to become a pi of out point, which is like this thing here from Pio 3. So yeah, I need to change a few things. It probably changes some assumptions because of that, because you can't, like, the fact that the type changes inside of structures can throw you off a little bit because you expect it to be something and then it's not that thing anymore. So uh, I don't know. I don't really like this solution, but I think it's the only way we have to make this work. Otherwise, um, you are basically forced to always make copies of your items, which means that then you can change them uh, in a nested way. Like you can do this, for instance, where you go o.inner.val. This would not, I mean, this would work, but in the end, o would still contain the old inner with the old val. It would not update the inner inside of o. So this was kind of the bug I was trying to fix with all of this. Yeah. So yeah, I just need to. I think I found the fix, but it's kind of a quick implementation. I should refactor that a little bit more.
Okay.
I think I could add some methods in here because there's a lot of shared code between C and Python. So I should find a way to, yeah, not duplicate it, I guess. Which is basically all of this code that goes through every field in a structure. And if you have this like syntax that says expose either a getter or a setter or both of them, it will do something. And this code is very, very similar between C and Python. It's just a different thing that it does. But the code to detect when to do it is basically the same. So I want to share that code and just have every language just implement what to do, not having to
Right.
detect it in both languages, basically.
Because they're both operating on the same pieces in a loop, sort of.
Yeah. So I think, yeah, I need to do this. So this is like the trait that you implement for every language that you want to support. The idea is that like you want to implement the C language and you have to define how to expose a function, how to expose a module, how to expose a structure. And this is like every language has its own like specific way to do this. So I think I'm just gonna add expose getter and expose setter
Yeah.
on this trait.
Yeah, this makes it nice.
Yeah.
I mean, having a module per language, it's going to be very clear. Someone wants to go implement some other crazy language, they can
Yeah.
just implement this trait, but they can also go look at the other modules to see how you did it for these other languages, and there probably will be some commonality.
Yeah, I think most of the time it's. I mean, I also did a lot of copy paste between the two languages and then just change the few specific things for that language.
Yeah, I think that's a reasonable approach.
So this is fields. Yeah, so I guess I should take a field here. So this is the name of the structure, the field that we want to expose, whether the structure is opaque. Yeah, I mean, I could also, I mean, alternatively, I could get the whole structure and just look myself if it's opaque, but I'm just gonna get it as a boolean. It's quicker. Yeah, and we
So
also
that's the
need
parent structure this field lives within.
Yeah. And this is like extra items that I want to create. So the idea is that I get a mutable reference to the field, so I can change that field. But maybe I also need to create completely new items. Like for instance, when I generate a getter, I need to create a new impl block with that getter. So this is, I mean, I can't change a field to add the getter in there. So I can change the field to maybe change its type, but then separately I
Yeah.
need to generate that. And this is part of this extra thing.
So potentially you're creating a new impl block per
Yeah.
field. Okay. I guess
Yeah,
there's
so
no harm in
I think
that.
I could show you here.
Because mostly this code isn't actually ever saved in a file. It's just done during compile time, right?
Yeah,
Or is there a way to
it's not.
expose that intermediate code?
You can use cargo expose. This is like a kind of I mean, it's not a default cargo command. You have to install it separately, but it's very
Okay.
useful for that.
I see. Yeah,
What?
that would make troubleshooting this stuff otherwise would be a hassle.
Yeah, it's terrible with. I mean, it's terrible even with it because sometimes I just get you have panics. Like if your procedural
Oh,
macro panics, you don't get
yeah.
anything out. So yeah, it's still terrible to debug it, but it's a bit better.
Yeah.
Uh,
Yeah.
no, sorry, it's cargo
Something like
expand.
that.
I just got it wrong.
I see.
Yeah, because
I
it
see. That
expands.
expands after
Yeah,
all of the macros are done. Okay.
yeah.
Yeah.
You can install it separately, and then it becomes like a new cargo sub command that you can use.
Okay.
Yeah.
Nice.
I think I'm gonna return the name of the function I create, because in some, I mean, not all of them actually, but in some languages, like Python, for instance, uh, you have to manually like add functions to modules. So I need to know the name of the function because maybe actually I could also, I think I can ignore that because I create a new implementation block and then I run that implementation block through expose impl of that language.
Mhm.
So it will probably do that for me. So yeah, I think I can remove that from here. And I think I could also
So that's
change
sort
this
of a
instead of taking like a vector of items, I can just take an empty block and just fill it in with stuff. Which probably makes more sense for a getter because the only thing you can really create from a getter is a function. So if you have an
you
implementation
already
block,
have
you
an
can.
existing function block, yeah, or implementation block, yeah. I see. So as you're looping through these, you're looping through your structure, somewhere near the beginning, you've already created an impl block for all the functions you're adding.
Yeah, I think I'm gonna do that and then give the same, like a mutable reference to the same block for all the getters and setters, and then at the end I'm gonna run that block through expose impl. So yeah, if we need to do some more processing on that, like for instance, adding all the functions to a module or things like that.
Yeah.
Okay. So now I need to implement those for, I'm gonna start with C and then I'm gonna do Python as well.
And all of this is, I know it's currently in your test project, but all this is eventually going to end up sort of in a separate crate, like a BDK bindings crate or something like that.
Yeah, I mean, I was thinking we don't even really need to publish those crates because, I mean, they're not really useful as Rust crates for other Rust crates. It's like very specific for our project. So right now this is a
Yeah.
local crate. It's in a subfolder called Derive. Uh, I think, yeah, we can just leave it in there because we don't
I see. Yeah,
need
yeah.
to publish it or anything.
Right. Right, because it's yeah, I see. Because you've got all of that code that's related specifically to the like the Rust Bitcoin and all the
Yeah,
BDK stuff that we're
I mean, I would
adapting.
kind of like to make it a very generic like framework that you can use for every crate, but uh, I mean,
Yeah,
maybe in the future. It's just too
that's
hard for now.
right. Yeah, this could maybe inspire someone else to do that.
Yeah. Gonna need the getter name. Obviously, the getter name is generated with get underscore the name of the field we're
Mhm.
processing. I think so. Okay, so every implementation block has a vector of items, which can be like multiple things. Could be a structure, a method. No, sorry, it's not structure, a constant, a method, a type. So yeah, we're gonna generate a new item imp method, I guess. I should also need this one. The problem is that Rust has a lot of like exceptions, little things that can change the syntax. So, for instance, it's not guaranteed that a field in a structure has a name. This is why it's an option. Because I don't really remember.
Would it be like one of those underscore names, you mean? Like if it was just a sort of
No, I think
anonymous
it's
thing?
yeah. So it says that because it treats tuples as like individual items of every tuple, it treats them as fields, and those are not doesn't have any name. I think so. This is
Yeah.
why it says so. This is an option of an identifier. So yeah, it's kind of tricky because there are a lot of those exceptions, and you have to. Uh,
Well, so so then what do you, how do you reference it? Like just as a, like a dot number after the
yeah, I think this
field
is
name?
yeah, because in tuples you use dot zero, dot one. You use like the index, so they don't have a
Yeah.
name.
Hmm.
Okay, and in C specifically, I don't create. Um, so if the structure is not opaque, I just don't do anything because in C you have access. If it's not opaque, you have access directly to what's inside, so you don't need a getter. So I'm just gonna if not is opaque. Okay.
Hmm.
Um, so for the setter, this is oh, and I should also I also need to know the original type before I change that. So basically like the type of the field. So yeah, we can add.
That doesn't exist in the field itself.
Yeah, so I mean I have to decide. Yeah, I could just read the field because I change it. So the point is if I change it before
Ah,
I get to this point, uh, this is why it's
tricky.
called
Yeah.
all the type because I need the original one. But yeah, I guess I could
Right.
just change it afterwards. So yeah, we
Or you
can do
could
that.
just save it sort of at the beginning, maybe. I don't know.
Yeah, I just didn't want to add a new because I'm not gonna change it in here actually, or maybe I think I need like a third method because I need to do it. Usually, I only need to do it once um, for both of them. Like if I update the type once for the getter and once for the setter, I'm gonna get the wrong type because usually what I do is
mm,
like if I have let's say like a string, I change this into a pi of string. But the point is, if I update it in both, I'm gonna end up with a pi of a string because I just take like whatever the type is and I just add pi around. And I don't want to add
right,
code to
right.
detect if I've already done it. So the point is, I'm just going to do it once, um,
Yeah,
and I'm going to do it outside of the expose getter, expose setter.
I see.
Um,
That makes sense. In that case, I see what you mean by field. This code is called in sort of a larger loop
yeah,
or sort of a larger.
yeah. I'm just going to read the type from the field right now, and then from the outside, I'm going to yeah basically change it. Um, yeah, so I need a new. Uh, Maybe I could actually do that as part of my expose struct, so I don't need like a specific
Mm,
method. I'm just gonna try to do it this way because I don't want to add too many of them.
that's because the expose always happens at the end. The
Um,
expose struct.
no, I mean the point is expose struct is the one that is gonna look at the individual fields and call. Um, oh, actually, yeah, but I wanted to actually share this part. Okay, so I need to find. Oh, I could probably use one of those uh, pre-implemented methods. So the idea is that for um, things that are generally the same in every language, we can add some methods on our trait that already have an implementation, which is like a default one.
Mm,
You can override it if you need something special, um, but yeah, this means that I would need a new method just for the type conversion. Yeah, okay, I'm just gonna go this way. And then I can have a provided method that does the conversion for every field.
spelling around generate.
Yeah. So I have I can basically copy this code from here. So this is the empty block that I'm gonna pass to every.
Okay. So that's the info block that all of the structures get their getters and setters added to.
Yeah, should be that one. I'm just gonna take the old structure, it's just easier. No, I can probably just stay here. Okay, so this is the name of the structure, the individual field, whether this is opaque, which I don't have it here, so because I get just gonna do this one. Okay. And then at the end I have to run this implementation block through our expose imp for that specific language. So at the end here. You need here. I also need to know the path. Okay.
This takes the path because it's actually, in this case, generating your 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 implementation language or your
This is basically like if I have a structure inside, like in this case, I'm thinking about the implementation block. So like in this case, I'm exposing this implementation block, and this one is inside the module test mod. So the path is gonna be just like just test mod, just one step. If you have nested modules, it's gonna be longer. And this is again because
oh, I see.
like in Python, you need to add every single function um, of this implementation block to that Python module. So I need to know to which Python module I should add all the functions. And this is why I need the
I see.
path is in the sense of uh, yeah,
Right.
structure
It's
of
a module
modules.
path.
Yeah.
Yeah, I see. I was thinking it was a file path. It's a module path. So,
No, yeah, it's
oh, you've got it right there. Yeah, you've got it there. I guess mod path. That makes
yeah.
sense.
Yeah, I'm not. I mean, I'm usually not the best at naming stuff, so I'm pretty sure some of my names are not going to be so clear.
Yeah. So far these make sense.
Okay. So yeah, I use a modpath. Okay, so I should define for every language how to wrap the field type. Um, or maybe I should return. Yeah, I should return like a boolean from expose getter, expose setter, which is whether I should wrap the type or not. I should document the stuff because otherwise it's not going to be super clear to, yeah, who reads this
What do you
code.
mean wrap the type? You mean wrap it?
Like the thing that was mentioning before, that if I have a string, I'm gonna change it into a pi of string in Python, or in C,
Uh,
if I have a string or like whatever type I have, it becomes a moot of that type. So wrap basically means changing the type of your field. Um, yeah, mainly because again of that problem where if you don't do that and you just use the regular types, you are forced to clone um, to constantly clone the
mm,
type every time, uh, like in every getter and then in all these places. And then if you clone the type, you lose like the connection between what you're returning with the original object, and you have that like bug where you can't update nested structures because every time you get a
mm,
copy out which doesn't update the original one. So yeah, it's kind of a
right.
mess,
Okay.
but
This is
uh,
where you were kind of wrapping it in a box, sort of thing.
yeah, so it just
Oh,
you are changing the type in a way that it lets you generate the getters and setter more effectively, basically. Um,
okay.
and every language has its own way of doing it. I mean, potentially a language could also not do anything to the type at all, but in this case, C and Python, they both need to do something.
Okay.
Oh no, maybe not in here. Should be in this other function here, which is the general one that exposes every setter. Um, oh, but this is not on a. Oh, maybe I can actually do it in here. I don't need to do it outside. Oh, I'm actually already doing it. I just forgot. Yeah, I was trying to do this thing again, but in expose struct here, but I'm already doing it.
Mm.
I just got confused. So no, it's fine. I don't need to do that. This is fine. So I can just call uh, from here. I can call the uh, generate getters and setters. But I need to go. Uh, Structure is opaque. Okay, so I think this should be it for the C language. Yeah, I need to define this wrap field type thing, which is pretty easy. I don't actually remember. I think I was doing. I'm just gonna go
So
back.
what is pass quote?
Sorry.
There's something. It looked like you were typing. Oh, parse quote. That's what you were typing.
Yeah. So that's. Wait, just a second. I need to go back a lot because I don't
Sure,
remember
sure.
what type I was like mapping to. Yeah, just a moot pointer. Okay. Yeah, there's probably a better way to do that. So basically, parse quote is a macro that again comes from scene. So basically, you write tokens inside, and it will parse that into whatever you want. So in this case, I'm returning a type. So type is like this enum here. There are many different like categories of types. You can have arrays or functions or yeah. And basically, parse quote uh, is just gonna do its parsing on the tokens I type between his parentheses, or you can also use braces if you want. So it's just an easier way of because otherwise I would have to build like the variant specifically for what I need. In this case, it just uh, does everything for me. And when you use this syntax, this basically means to capture the tie variable and put it in here. You can do that with every variable that implements two tokens because what it's doing like underneath is it is transforming type to the tokens that make up that type, uh, and then it's gonna parse this token plus all the other tokens into a new type, um, and it's gonna return it as type here.
Okay.
So I think I can try to compile this, and it's.
You had a little typo back there. Sorry, I think you
Where?
mistyped parse. Where you just were.
Here. Oh yeah.
There. Yeah.
Thanks. So I can try to compile this, and it's very likely gonna be broken somewhere. But okay. So
Yeah.
missing imports mostly. Okay, so the field's name. Yeah. Wait, is it? Oh, okay. So I. Oh, okay. So it says that I have like already borrowed this immutably, so I can also borrow mutably, which makes sense.
Mhm.
I should just clone that. Oh no, it's just yeah. I could also just don't need that anymore. So wait, what is this? I think this was working in here for some reason, and it's not working in there anymore. So
Using,
I'm pretty sure I was doing this. Let me check the Python code. So yeah, I'm just doing this and it's working. Oh, do this. Oh, okay. That was, yeah. This is the kind of error that I say are very hard to debug because the attributes, the attribute panicked somewhere, uh, probably because in one of the parse quote blocks, I have something that's wrong, so it can parse it. But I have no idea where, so now I have to kind of understand where it's coming from. Maybe sometimes with cargo expand, you can, yeah, no, basically what happens is it doesn't expand that at all. So it's just completely missing and you can't, you just have to guess a little bit. Um,
right. Is there any way to put like debug lines, printouts or anything? I guess it doesn't,
uh,
you're not really running the code. So
yeah, I don't know. I haven't
in
really
the
found
compile
a
step,
nice
right?
way for that.
Yeah.
Usually just comment out parts until it starts working. So
Ah, right, right. Okay, that makes sense. Process of elimination.
yeah.
But you
Uh,
know that it has to, do you know that this error message, this thing is breaking somewhere on that particular, like that's the like it's all, the problem is somewhere in this exposed mod
yeah.
attribute, right?
The error is like the panic message is um, basically that it was expecting that different token than what it found. So it's very likely inside of a parse quote where I am, I don't know,
Mm,
I'm just passing it the wrong token. So I can try like,
I see.
yeah, I'm just gonna start commenting out stuff until it
Okay,
works.
sure. Yeah, this is good for me to see how these things get debugged.
Yeah. So expose get. think maybe one thing is also, I don't know if an empty block like this is fine. It probably is, but I don't know.
Mm,
So I'm just gonna try and add like a random thing
right.
just to make sure it's not empty. And this is an item imp. That should be the right. Yeah, so basically an implementation block. All right. Oh yeah, no, this is actually yeah, there should be the structure name here, I think, because I'm implementing those on a structure. So wait, let's try.
Right. You've got the item structure. It's there.
Yeah.
Oh, I see. You have to get its identity somehow.
Yeah, because I'm like this implementation block is on this structure basically.
Uh-huh.
Let's see if this works. Okay, so this worked. Now I can uncomment those. All right. So
Nice.
okay, so we can see with expand.
Yeah. Okay.
Okay, so I don't think it did anything. Sorry.
I was going to say that you should see that structure with those generated implementation block on it.
Yeah, so I think now it's correctly not generating them because the structure is not opaque. So there's this rule that I was saying before that if it's opaque,
right.
if it's not opaque, you don't need to. Oh no, okay, it actually is opaque. So they should be in here. Maybe I just missed those, or no, I don't think they're in here. So I just probably forgot to add them back or something. Oh yeah, maybe I should add them back to the extra thing I was mentioning. So like.
Oh, I see at the end, basically.
Yeah, inside the expose struct. Yeah, so I'm basically generating them and throwing them away, I think, because I have this implementation block, but
yeah,
I never
but you're not adding the getters and setters to it.
Yeah, so I should. Oh yeah, I could return that one, which makes sense. Generate getters and setters, and you get back an implementation block with those. And from here, I should extra. Okay. Okay, so these are the getter and the setter. Maybe I should. So there's one thing I do in C, which is I always add the structure name as a prefix for the function, because otherwise, if you have like let's say type A and B, and you have the new method on both of them, they both get mapped to a new function, just a new, and it conflicts because you have two new functions. So yeah, I added the structure name as a prefix, so it becomes like a underscore new. But yeah, I think it makes sense because yeah, outer get inner. I think it makes sense. So outer is the structure on which this is implemented, and you want to get the inner field of that. And you should see that the
is inner the name of the field?
Yeah.
No. Okay.
So yeah, basically the type. So I declared that it was just called inner, the type. So it was just the type itself, and it gets expanded to a mutable pointer because this is how we wrap the type in C, and in Python it's going to become something else. But
okay, that's cool.
So yeah, so
I see. Because the C code, I mean, you're just going to get all these functions as a big list of functions, right?
Yeah, so they all end up in the header like this. I was thinking about
I see. Yeah, it makes sense.
trying to generate like different header files for every module. So like every module has its
Mm.
own header file, but it becomes a bit of a mess because then you have to make sure that you import, like in the BDK header file, I will need to import the Bitcoin header file because BDK uses Bitcoin types. And this is not, I mean, you need to actually like start to
Yeah. You have
build
to
kind
do a
of a
whole
tree
dependency
of
tree sort of
yeah.
thing.
So
Yeah.
it becomes kind of a mess. So I'm just making just
Yeah,
one
yeah.
big,
No, yeah, I think that's a good way to go.
yeah. And I should remove this do nothing function, I guess, because
Oh,
yeah,
because you
that was not
don't
the
need it.
problem. Okay. Okay, so
So now
now
we
I'm
just
gonna
see your,
try. Sorry.
yeah, so that's fine. We just see the inner stuff now.
Yeah, I think I can just try um, using it from C, like just to see if it works and everything. So like
Mm.
I can reproduce, this was the Python example. So I create a new inner with a value, random value. Then I create an outer that contains that inner. And then I try to update the value of the inner inside of O. So this is like the nested access that was broken, basically. I can try to reproduce that in C and see if that works. So it was working with the non-opaque structures because you could just look inside them. Now I want to see if it works with the opaque structures where you have to use the
But in the,
getters and setters.
right, for the non-opaque structures, they were primarily just heap values and stuff, right? I mean, it was,
Yeah, I mean for the um, non-opaque structure, you can just write directly into them, so you don't need to go through
yeah.
any. The problem here was if you were going through our getters and setters, that it was breaking basically. So the inner structure is still non-opaque, and it doesn't really matter because the point is we want to see that you can update inner when it's inside of another structure that is not opaque, I guess. Or we could also,
Okay, okay. Yeah, I see.
yeah, no,
Yeah,
I think this is fine. I'm just gonna try like this and then see
yeah.
what happens. Um, so actually, I don't think you can do that because outer expects a pointer to inner, not like the all inner structure, just a pointer. And I think it expects the pointer to be allocated on the heap. But if you have a non-opaque structure, you can allocate it on the stack, and then it breaks. Yeah, I'm just gonna try. It should break, but I'm just gonna try to confirm that it
Yeah.
breaks. Um, yeah, okay, let's try it like this. So um, uh, so I just like print out the value, try to multiply that, and print it again. This should work because I'm not like triggering uh, the allocation of the inner type. So this should work. Let's see. Yeah, it works. So it was 10 and it becomes 50. So this is fine.
Mm.
The problem here is if I mix up, no, even just, I think just using the setter. So I create a new inner type down here, which has a different value, like 1000. And then I try to set, so I use the setter on my outer type to change the inner type, which is outer set inner. And this should fail, like this should crash, because when I do that, I'm gonna try to free the previous pointer I had. So the pointer I had was this one that I was getting here, but this is a pointer to the stack. So if I try to free that, it should fail. And I actually got to this point before, and now I got to this point again. Like before you joined the stream, I was doing those kind of tests, and I got to this crash. Okay. But I don't know. Let's try. So then I try to print it out, but it's probably not gonna get to that point. No, wait. Why did it work? Okay, I don't know why this is working. So this line here should try to create a box from, oh no, okay. I think, oh, maybe it works because I'm actually cloning it. So I'm not storing directly a reference. So in my constructor, so in the constructor, in the outer constructor, which is this one, I think this is implicitly, yeah. So this was that thing I was saying, that we always clone in the setters, and the constructor is kind of a setter in a way. So I'm not storing directly a pointer to that. I'm actually cloning it. So it's fine because I clone it and I put that on the heap. So then it's fine to free it this way. Okay, so this is actually more. So yeah, I thought I would have needed to change the API somehow to basically make sure that you couldn't do this, but actually you can do this and it's fine. So actually, let me check that we are not leaking memory or anything. I need Valgrind. Okay.
This is a tool that helps you find unfreed memory or something.
Yeah, it's basically like kind of a debugger for memory issues of almost any kind. It's very powerful. I think the way it works is that it kind of sits in between like the executable you're running and the operating system. So when you allocate memory, it will catch like the fact that you are allocating memory and store some metadata about like where are you allocating that memory and the pointer and the size and everything. And then like for instance, when the program ends, it will look through its like table that it builds and see if you freed every piece of memory or if you forgot to free some of them and things like that. Wow. So I don't really know how it works. Cool. Yeah, but it's very useful.
Yeah. Okay.
Yeah.
Sort of a general purpose garbage tracker.
Yeah, no, I mean, it slows down execution quite a bit because it does, I mean, when your program makes an allocation, it does a lot more stuff.
Yeah.
But yeah, it's very useful for testing. So okay, so there is actually a leak of memory. 8 bytes. I don't know exactly what's the difference between definitely lost, indirectly lost. But yeah, the point is there are memory leaks. So
yeah, okay.
but 8 bytes is not really that much. I don't know, because I noticed sometimes I was getting like memory leaks when in fact it was just like a printf. No, it was actually a print ln from Rust. I don't know what it does internally, but basically it was telling me that the buffer that it was using to write the string was being leaked, which I think is just because the
Mm.
program ended and it had not been explicitly freed, but it was not even leaked. So I don't know.
Right. It would have been freed when it just never went out of scope before the program ended, sort of.
Yeah, I think something like that. But it was probably in the still reachable, which probably meant that there was a pointer to that data somewhere, so that you could free it if you wanted.
Uh,
And in this case, definitely lost. I
yeah.
think it means that you lost the pointer to that memory, so you can't free it. So
I
there
see.
should be a way to get like the exact point um, where the allocation happened. Yeah, which is in outer new alloc. So this is where the memory was allocated that then you didn't free.
Ah, that's pretty nice. It actually shows you the function and the line number.
Yeah. So this is a box that I'm creating. Oh, okay. So I think this is just um, yeah. So I think I should implement a custom uh, destructor for this because I'm changing this type to become just a pointer to. So instead of being like the owned value, I change this to become a pointer, but I never free this pointer. Like when this structure is destroyed, I don't free the internal pointer. So I'm just gonna try writing it manually, and if it works, I will like automate it.
Mm-hmm.
So in this way, we kind of take ownership of that pointer. So we put that pointer into a box, and then we just drop the box at the end of the function.
Ah,
Um,
okay. Yeah.
so that should free it. Um, no. Colton say, yeah, you're right.
Yeah. Very unsafe.
Yeah. Okay, now. Okay, so it's still complaining, so I don't know where.
Uh, hmm.
Oh, okay, so I think this is actually C. I should destroy outer. So I think actually I think I need this custom
In your
destructor, but it's never being called. So I can add a println just to, because
this has to be triggered by something their C code is doing.
no, I think it's basically the C code should destroy. I forgot to explicitly destroy the outer type from this C code. So
Mm-hmm.
basically, the destructor never runs um, because it's C that as a pointer to this structure. So it's a responsibility of the C code to destroy that
I see.
once it's done.
Right. Okay.
So yeah,
Yeah.
I'm just gonna try this. It should not print this line, and then we add the destructor, and it should start printing that line. Yeah, so it just printed the numbers. Um, so yeah, I need to add a destructor here. Yeah, I could also generate those automatically. So right now I'm doing them manually, but I should do that automatically because it's always the same thing pretty
Right.
much.
So you're giving this method to the C code to call when it's done with
Yeah,
that.
exactly. So it's gonna become outer destroy, so outer underscore destroy. So here at the end,
Mm-hmm.
I'm gonna do.
So I guess it's a case where the Rust code automatically allocated it, but it doesn't.
Yeah,
It's handed it off to the C
Okay.
code, so the C code now has to decide what to do with it.
So destroy outer
Okay.
worked.
Yeah.
And yeah, so this is I think what I was talking about. It says that
Yeah.
there's a leak for like 1 kilobyte, which is still reachable. And if you like show where the leak is coming from, it's from some println. So yeah, it's like stdio print, std out something. So this is like internal Rust stuff.
Yeah.
But yeah, I think it's fine because it says that it's still reachable. So I think the point is you didn't explicitly free that
Yeah.
memory, but you still had a pointer to it, so it's fine.
Yeah. You don't have those indirect or directly
Yeah.
lost bytes.
So in theory, if I remove this, that should also disappear.
Yeah.
Yeah, this is, yeah, all e blocks were free. Okay, so
All
now
good.
I need
All good on the memory
to,
front.
sorry?
Yeah, it's all good on the memory side.
Yeah. So yeah, so I need to generate a custom destructor when I change the types, I guess. So if you generate when I wrap the types, I should say, because I called it this way in the code.
So so when you wrap an opaque structure
Um,
or the elements of that structure.
I think it depends specifically on the elements in the structure. So because if you just expose a structure, but you don't touch the inner like members, it should be fine. In this case specifically, it's because I'm changing this to become a pointer. So it's actually kind of a C specific thing because I don't think this happens in the other languages. It shouldn't happen in Python because I think it is correctly destroyed. Like I think Pyo3 handles um, all of that for you. So this is kind of a C specific thing that I should do.
Okay.
Or alternatively, I guess I could um, do that in the destructor down here. I don't know. It feels cleaner to do it this way because it means that if you drop, because otherwise you would have to use the destructor even in Rust, which is not ideal because in Rust you usually don't do that.
Yeah.
So it's better to do it
Right.
like in the Rust way, so you get it for free both on C and on Rust. So
You're
yeah,
saying that
I should.
basically this drop stuff should happen in your C adapter code.
Yeah, because I think this is just specific for C. So yeah.
Because when you do an implement drop here, it's overriding whatever the Rust default implementation would be.
Yeah, I mean the default implementation I think still runs. So this is like something you can do kind of on top of it.
Oh,
So I think
okay.
this runs just before the real thing runs. So basically, if I have like, in this case again, the problem is that I'm turning this into a pointer. So then when you turn that into a pointer, it's your responsibility to free it. But if I have like a string, for instance, like this, and I'm not exposing that, so this one remains a string, I think it will still free the string automatically. It's just that basically I have a chance to do something if I have to before. In this case, I'm gonna free this field, but then the default kind of destructor that would free string still runs afterwards.
Okay. Okay.
Yeah, so I think I should, I don't know, just find a good way. Maybe I could return which fields were modified, and then I can take that and manually free all of them. So like in this, yeah, because this is where I do the wrapping basically. Yeah, I'm just gonna, I mean, it's not super clean. I'm just gonna change this to also return the names basically of the fields that I wrapped. Oh no, actually this is the thing I was saying before. So you don't always have a name for the field, so I should take that code with the expect from here. Field something. No.
So what are you doing with those? Are you giving them a different name? Like, are you making up a name?
No, I'm just returning the name for every field that is wrapped, basically. So this is the function that generates getters and setters, and this is where if I generate either a getter or a setter, or well, even both of them, I also wrap the type, and I'm also now gonna return, since this all happens like inside of here, the caller outside doesn't know which fields were updated, and it could be all of them, just some of them. So I'm just gonna return which, like the name of the fields that have been updated or wrapped.
I guess I wasn't sure what you're doing about the names of those of those tuple fields.
No, I'm
Or
just
tuple.
returning.
Oh, I guess,
Uh,
the name, they'll still have a name, right?
oh, so you mean like if you don't have a name? So like, what happens if you get a tuple
Yeah.
or something like that? Yes, just gonna crash. um, and yeah, so
Okay.
the idea is we don't support
Yeah.
tuples. Yeah, so there
Okay.
are a lot of
Yeah.
those uh, not supported stuff around the code. But I think it's fine because I mean it's just our code, so we know like the limitation of the tool, and we know that we should
Yeah.
follow like those patterns.
Yeah. Also, I mean, yeah, for public API, tuples are probably a little bit unfriendly.
Yeah, and also you can't expose them to C very easily, probably not even to Python all that easily. I don't know. So yeah, it's just better to
Yeah.
not expose them.
Yeah. It's easy to convert a tuple to just a small structure if you need to.
Yeah. Um, yeah. So this is where I yeah, I keep changing this. I place it up here so that it's like available to the entire function, and then I don't need it anymore. So I remove it, and then I need it again. So I should just leave it there. Okay, so there's also this syntax which is pretty cool that you can use to basically iterate over, like in this case, I have a vector of fields that I need to free. Oh no, actually, I don't think I can do that, but I could. Yeah, I think I should map them first. Something like this. Um, so first, for every field, I generate like this line. I generate one for every field with obviously a different name here, and then I take all of those and I put them down here in the actual like destructor. I'm just gonna use quote here because I don't really care about uh, parsing that. So these are just tokens. I don't really care about them. I just wanna add all the tokens in here. So we use quote,
With
which is another. It's another macro that it's kind of like parse quote, but it doesn't parse the content. It just returns the tokens.
I see, but it'll take field in as a variable there. Okay.
Yeah. So it will. Well, I will show you once this is done. And then with this syntax, you can basically iterate. This is taken from the normal Rust macro syntax that you use to iterate over, like, I don't know, if you have multiple tokens being passed to a macro. Yeah, it's, I mean, kind of hard to understand, but I mean, not to understand. It looks weird at first, but
Yeah.
you get used to it
Yeah,
after a
the
while.
macro syntax is a bit different, but
Yeah. And I also need to add this to the extra thing. So now I will show you how this thing is going to look like if it works. Yeah, so this is what gets generated. So this is all like fixed, and this is the, oh no, wait, I think I still have the, yeah, maybe I should remove this one because otherwise we can confuse. Okay,
you
no,
get
so
two
this
of them.
was the, so there were two of them. So this is actually the one that got generated.
Okay. Looks just like the other one, more or less.
Yeah. So yeah, it's basically the same thing, but
I see. So jump on the drop for I see. So
I'm trying to
drop is
think.
a trait.
Yeah, I don't know if something bad is gonna happen if I have multiple fields, because all of them are gonna be called underscore free, but I think it's just gonna like shadow the name of the previous variable, so it should be fine. I'm just gonna try it
Yeah. Yeah.
just to make
Yeah,
sure.
that'd be interesting. I see. So it's actually creating just a single drop method. That's the drop for that
Yeah,
outer structure. Okay. And then it just frees all the inner fields.
yeah, like that. So I've added another field
Okay.
of
Yeah.
type inner, but called inner2, and this should be fine. I'm gonna cargo check. Okay, well, yeah, I mean, it's complaining about the constructor here because I'm not giving anything to inner2, but yeah, so it's not complaining about the duplicated name. Okay, so this is pretty cool.
Yeah, very cool.
Yeah, I'm gonna do that for Python, and then I think I'm gonna take a break because I've been,
Okay. Yeah. You've been coding all morning or all afternoon for you.
yeah, also all morning for me.
Oh,
But
all morning too. Okay.
yeah,
That's a long day. Yeah, this is some intense stuff too. This is not
yeah.
trivial coding.
Or maybe I should check. I
Um,
mean, I don't really think anybody's gonna watch those. Yeah, okay. No messages. It's fine. But yeah, I'm always afraid I'm gonna miss some messages in the chat or something. But
on Twitch, is that
yeah,
where it is?
yeah. On Discord, I should have the notification like sound, so I understand if somebody sends me a message or something. But yeah, I
Yeah,
think I'm
it's
doing
very cool.
this mostly like to. I think it's pretty good exercise for like documenting the progress of what I'm doing. So I think this, even
Mhm.
if nobody else watches those videos, I think it can be useful just for myself to go back if I need to. Um,
Yeah,
I don't know, to just see why I did something, because I always forget the stuff. I
yeah.
keep asking myself, why did
But
I
it's
do it
definitely
this way?
useful.
Yeah,
Yeah, definitely useful for me because this is, I mean, it sounds like my goal, I guess, would be to be able to write one of these adapters for Java. Like that's probably my most immediate goal is just to try to do that. So
yeah,
seeing how you're doing it here for C and for Python, it's probably going to be more similar to your Python work, but um, just to kind of watch you do it for one of these languages gives me a good idea
yeah.
where I need to look and what I can use as an example to follow too, because that's
Oh,
most likely how I'll be doing it.
yeah.
you know.
Actually, we can also,
So,
I mean, not right now, but we could also generate the Java code right from the procedural macro, because like this code that's running, you can like literally open a file and write stuff into it. So you can open a file, you can create a new file called, I don't know, hello world.java and write the Java code
uh-huh.
inside, and that's fine. I mean, the compiler doesn't really complain or anything, which I mean, it's not really good in terms of security, because it means that if you like compile a random crate from somewhere, that crate could access your file system in this way. Um,
Right.
yeah, which is not
Start
great. I
creating
mean,
random programs.
yeah. So I don't know.
But like, how are you doing? I mean, this must be similar to the, well, I guess, what is the Python one? Because it's generating Python code, right?
Not really in this case because Pyo3 does most of the stuff. So I don't really do anything in
That's what I
terms
mean,
of Python.
but PyoTree, but that's what PyoTree is doing. PyoTree is generating Python
Yeah,
code.
I think it is. I don't know that. I mean, again, it kind of depends on every language. Like
Hmm.
maybe in Python you can just get away with just pure, basically native code. I think you can like,
Calling just the FFI, right, right, right.
I think yeah, you can define like a class and its methods and everything just in native code, and then when the interpreter
Hmm.
loads your like shared library, it will find everything. So I mean, I don't know. I think maybe
Yeah,
they
I
do
think probably
generate
for the,
Python, but
yeah, I would actually say probably for the Java code, first step would, if we're going to generate anything, it would just be that the JNI capable um, C code, basically.
yeah,
Like the C code that's set up to be loaded as a JNI module or exposed as JNI,
yeah,
and then we can, once that's working, because I think that's going to be the hard, once that's working, that's going to be most of it, and then yeah, we can see about exposing it as actually generated Java code, which would be very cool too.
yeah,
Um, I'm sort of counting on the fact that eventually these sort of APIs are going to not change that much. So if we have to do a little bit of hand coding, it's not going to hopefully change that often.
yeah. In theory,
But
yes. I mean,
like
once,
Java or whatever. But yeah, if we get to the point where it's not hard to do it automatically, that's even better. So let's
yeah.
see where that goes. But okay.
I was thinking that maybe I could remove the is opaque from here because it's like very C specific in a way.
Hmm.
Um, oh no, but yeah, the problem is I need to pass that into here because then it gets passed down into those. Because like in Python, you don't really care if it's opaque. You always generate the. I mean, in Python, it's basically always opaque in a way because
Right.
you can't access directly what's inside you. You always need to go through. So yeah, I think I'm just gonna hard code that to true in Python, and yeah, that should be
Yeah, I
it.
think in Java it'll always be opaque too. I'm pretty
Yeah.
sure. That's a whole different runtime basically.
So is opaque. It's true. I don't need a destructor, I think. So yeah, okay, so this should be it for this part. Now I need to generate to define how to generate the getters and setters, which is this thing here, this thing here, and then how to wrap the type, which is this here. So I'm gonna take those. Is this worked? Yeah. Okay, so I need to define this expose getter, expose setter, and wrap field type. Actually, I think I'm gonna copy them from C. So this is what we do in Python. Basically, in the getter, we um, clone the reference from our field. So we're not cloning the object. We just basically, I think it's a reference counted thing inside. So we're just like increasing the reference count and then copying the pointer. And this is what basically allows us to get out something that modifies the original object inside. Okay, so this compiles. We can try running this example here to see if everything is being generated correctly.
That's kind of
Yeah. So I'm gonna is this okay, I have no idea why it is happening. Okay, so I don't know, looks fine. Yeah, so it was 10 and we multiply that by 5 and it becomes 50. This looks, yeah, pretty good.
so it's basically a similar inner adder test, but in Python.
Yeah, so it's, yeah, basically the same thing here. I mean, here there was also the other, we could also try that, where I mean, it starts with 10, we multiply that by 5, and then we replace it with an entirely new one, which is 1000. Yeah, it's much faster to prototype those stuff in Python.
I guess, do you have to worry about the memory issues in Python either? Like, is it, because you said it like it's already automatically jittering those things for you?
I think it
Yes.
does. It's mostly PyO3 handling everything. So like you don't need a destructor because it will, I don't know, do its stuff.
Right. It's tied into the way Python lets memory
Yeah.
go.
Okay, so this is nice. I'm gonna
Yeah.
commit
Oh,
that.
great. Okay.
format and commit that.
Which branch is this going to be in? This is your work in progress branch?
Yeah, this is still
Oh
work
yeah,
in progress. Yeah.
Okay.
Yeah, I did change quite a few things. So, but yeah, I'm just gonna commit it like that. Still
Okay. Yeah.
work in progress. Uh, yeah, I think this sums it up. Yeah, I'm just gonna leave it like that. I mean, I'm not really trying to
Sure.
make super nice
Yeah,
messages or anything.
this is yeah. I wouldn't worry about that at this point.
Nice. Yeah.
Yeah. I think one of the things I'm going to try this afternoon is just pull down your code and just try to walk through myself the things you've been doing. Just make sure I can compile it basically and run everything.
Yeah, I mean, if you have any questions, I don't know, text me, write me on,
Yeah.
or even in the maybe in the public public Discord channel.
I'll use that. I'll use that.
Yeah.
Yeah, I'll use the FF5 bindings in case anyone else starts to do it. They can see those questions.
Yeah.
There's probably some tools and stuff I'll have to get installed. But once I'm at that stage, then I can start goofing around with it. And I mean, I'm not going to be committing anything, but just to make sure I can walk through it and figure out where all the pieces are and how to use them to make my own stuff, to make the Java stuff.
Yeah. Yeah, I also think I should start like documenting all of this stuff, but I mean, I haven't really started doing it yet because I'm still changing them a lot. So I don't want to spend time documenting something and then I
would
throw it away. So
yeah, no, I wouldn't worry about documentation until the very end. And I think these videos probably are better documentation at this point,
yeah,
because anybody who wants to, this is the pre-release stage that wants to get the latest and greatest that can catch up on
yeah,
your stream, because this is where it's really happened. This is where it's actually most up to date.
yeah.